Hello class, today we are going to talk about effects of three-dimensional change. So what happens to surface area and volume when we change some of the dimensions of a figure? So let's just jump on into this. Describe how doubling all of the linear dimensions affects the surface area and volume of this rectangular prism. So we are going to double all the linear dimensions. So when it talks about linear dimensions, it's talking about length, width, height, those things. If this was a cylinder radius, anything that you can measure like that with a ruler is linear dimensions. So we're going to double all of it. We're going to double the length, we're going to double the width, we're going to double the height. And the easiest way to look at this is to set it up in a table. So here we go. We're going to have a table. We're going to have our dimensions, what happens to surface area and volume, what it is before the change, what it is after the change. So before the change, we have a length of 4, a width of 3, a height of 6. And after the change, when we double all of the dimensions, we have a length of 8, a width of 6, and a height of 12. So let's take a look. Surface area. We're just going to work this out real quick. So we start with our formula, which is lateral area plus 2 bases. So lateral area is perimeter of the base times the height. And then the base, since it's a rectangle here, that would be length times width. And we have 2 of them. So 2 times length times width. So plug in what we have there. So perimeter is 2 times 4 plus 3 times the height, which is 6, plus 2 times 4 times 3. Which gives us 108 square feet. All right, let's go ahead and do volume, and then we'll take a look at what happens after the change. So with volume, area of the base times the height. Well, the base is a rectangle, so that would be length times width. So length times width times height is 4 times 3 times 6, which is 72 cubic feet. Remember, surface area is in square feet, volume is in cubic feet. Okay, so after the change, what do we get? Well, let's see here. So same formula, just we got new numbers, right? So perimeter is now 2 times 8 plus 6, so 2 times 14 times 12 plus 2 times 8 times 6, which stick that in your calculator and you get 432 square feet. Okay, and what about volume? Still base times height. Base is still length times width, just we got a new length, new width. So we have 8 times 6 times 12, which is 576 cubic feet. So what happened to this? What was the change here? Well, easiest way to do that, let's take this and look at it as a ratio, right? Remember, when we're looking at scale factor, things like that, it's always going to be new over old. So 432 divided by 108, which is 4. Notice it did not double. We doubled all the things, but the area went up by 4, not 2. All right. What about volume? Well, volume, we're going to take the new over old. So 576 divided by 72, which is 8. Also not 2. We doubled everything, but the area went up by 4, and the volume went up by 8. Okay, so we'll take a look at that. But anyways, so we see that our surface area went up by a factor of 4, and the volume went up by a factor of 8. And so that's how we can describe the change here. Okay, let's take a look at another one. Let's do same problem, but this time we're going to triple everything. We're going to see if we can find a pattern so we can shortcut this. So if I triple everything, then the length becomes 12, the width becomes 6, and the height becomes 18. Sorry, tripling it. So width becomes 9. 3 times 9. Okay, 3 times 3 is 9. Okay, so we're just going to plug everything in. So same formula. So now we have 2 times 9 plus 12 times 18 plus 2 times 12 times 9. Right? Which gives us 972 square feet for our new surface area. The original was still 108. And for volume, still base times height. And just now we got new ones. So 12 times 9 times 18, which you stick in your calculator, and you got 1,944 cubic feet. Okay, so let's take a look at how this change was. So we took everything, we multiplied everything by 3, but the surface area, let's see, new over old, is, okay, so the surface area went up times 9. 108 times 9. Okay, even though we multiplied everything by 3, we end up with times 9. Volume is going to be 27. Okay, so surface area increased by a factor of 9. Volume increases by a factor of 27. So let's take a look at this. Let's see if we can find a pattern here. Let's just take a look. So scale factor of 2, the surface area went up by 4, volume went up by 8. Scale factor of 3, surface area went up by 9, volume went up by 27. Well, if you look at this, you'll notice, let's see, from 2 to 4, 3 to 9, well, that's just 2 squared. And 9 is 3 squared. So we're just taking the scale factor and squaring it. With volume, or to get from 2 to 8, well, that's 2 times 4, so that would be 2 times 2 squared is 2 cubed. And the same thing works here. 3 times 3 squared, right? 3 times 9 is 27, so that's 3 cubed. And this is the pattern. Here's the thing. Shortcut. If all of the linear dimensions are changed by the same scale factor, then the surface area is changed by the scale factor squared. Volume is changed by the scale factor cubed. And one way you can remember this, back here, surface area is measured in square units, so you're going to square the factor. Volume is measured in cubic units, and so you cube the factor. All right? So that's what happens if you change all of the linear dimensions. So I want you to do this one. Take a look at this and tell me what's going to happen if we change all of the linear dimensions of this cone by a factor of 2/3. Pause the video, work that out, and then come back and check your answer. All right, so you're back. Let's see, we're changing all of the linear dimensions, and I want to know how it changes. Now, I could set up a lovely table and work this all out, except I know that all I have to do is take my scale factor and square it or cube it, right? So my scale factor is 2/3, so what I'm going to do here is take my 2/3 and square it. 2/3 squared is 4/9. Remember, when you square a fraction, you square the top, you square the bottom. So 2 squared over 3 squared, 4/9. All right? And for volume, I'm going to cube the scale factor. So 2/3 cubed is 8 over 27. 2 cubed is 8. 3 cubed is 27. And so let's see here. If I'm going to multiply by a factor of 2/3, then that means scale factor is going to, notice this is less than 1. So that means my scale factor is going to decrease. Where's my thing? There we go. It's going to decrease by a factor of 4/9, and my volume is going to decrease by a factor of 8/27. Anytime you multiply by something less than 1, 2/3 is less than 1, that means that it's going to get smaller. If it's more than 1, then it gets bigger. So scale factor, that. So this is decreasing because I'm going to have a smaller cone. All right. So that's what happens if you change everything by the same factor. You multiply everything by the same number. What happens if you don't? All right. So let's take a look at this. Describe how tripling only the height affects the surface area and volume of our prism. So this is the same prism we had before, but now we are only going to triple the height. We're going to leave the length and the width the same. So here's our originals. And so now we have a length is still a 4, width is still 3, but now the height is 18. So we take a look at our formula. Notice over here I broke this down into lateral area and the bases. All right. So this is our lateral area, this is the base. So we have perimeter is 2 times 4 plus 3, that's same as before, but now the height is 18. And our base is still 2 times 4 times 3. Notice this isn't changing. And so when we get our lateral area in our base, notice the lateral area changed, but the base did not. The bases are still 12 square feet on each base for a total of 24 for the bases, which gives me a total of 276 square feet, which you can look at this and tell real quick that it did not triple the surface area, did it? Now let's figure out what is that ratio. Again, remember, it's new over old. So 276 over 108 is approximately 2.556. It's 2.555, it's repeating decimal. Approximately 2.556. not 3. So tripling the height did not triple the area. All right, didn't even go up by 3 squared, did it? No, because we only tripled one dimension, not all of them. And so it does weird things. Notice the lateral area got tripled, but the bases stay the same. So let's take a look at volume. Volume, still same formula, base times height. Bases are the same, still 4 times 3, but the height is now 18. So we have 4 times 3 times 18, which is 216. So the ratio there, new over old, is 3. Not 3 cubed, just 3. So we tripled one of our dimensions, and that's what happened to the volume. It tripled. All right. So the surface area increased by a factor of about 2.556. The volume increased by a factor of 3. Okay, so let's take a look at this. Let's do another one. Describe how tripling the radius affects the surface area and volume of the cylinder. Okay, so this is a new picture, so we're going to work this out. So before the change, our radius is 3 and the height is 6. So surface area, again, lateral area plus 2 bases. So 2 pi r h for the lateral area, and that's circumference times the height, plus 2 pi r squared, because it's 2 bases, so 2 pi r squares. So we plug this in, radius is 3, height of 6, radius of 3 there. We get lateral area plus bases. And I'm going to leave this all in terms of pi because it's going to be easier to see our ratios that way. And so I have 54 pi square centimeters. Volume, formula is the same as the area of the volume of a prism. Base times height, area of the base, remember. So area of the base is pi r squared times the height of 6. And that gives me, weirdly enough, also 54 pi centimeters cubed. Not centimeters squared, centimeters cubed. Okay, so after the change, we're going to triple the radius. So that means the radius goes to 9, but the height stays at 6. Okay, so same formula. 2 pi r h plus 2 pi r squared. So we plug in 9 instead of 3 for our radius. And notice this time the lateral area changed and also the bases changed. So we changed both of them, which gives me a total surface area of 270 pi centimeters squared. So it was 54 pi, now it's 270 pi. Let's take a look at this. So that gives me a ratio of 5. We tripled things, and my scale factor came out to 5. All right, so that does not seem to be following much of a pattern there. Let's see, volume, still base times height. So we have pi r squared h, which r is 9 now, and that gives me 486 pi. So let's take a look at that ratio, and that comes out to 9. So we tripled everything, and this ratio came out as 9. So that is 3 squared, so that one's still kind of doing something along the lines of what we did, but it's not quite matching up, is it? And surface area has nothing to do with 3. All right. So surface area increased by a factor of 5, volume increases by a factor of 9. Now what is happening, if you'll notice, here where we tripled only the height, we tripled only one dimension, and so my volume went up by that scale factor, once, times 3. Here I tripled the radius, which means I'm tripling the length, and I'm also tripling, I'll give you a color you can see that. I'm also tripling the width, because radius is both length and width, right? So here I'm tripling 2 dimensions, length and width. And so notice my volume went up by that scale factor twice, 3 times 3 again, so 3 squared, right? So I have 2 dimensions, my volume goes up by the scale factor twice. If I change just 1 dimension, it goes up by my scale factor just once. And if you changed all the dimensions, it goes up by the scale factor cubed. Okay. Surface area, on the other hand, yeah, it is not following any kind of pattern at all, is it? No pattern at all for surface area. So sadly for surface area, you're gonna have to take this and work it all out. Volume, not so bad. Whatever you're multiplying the dimensions by, that's what you multiply your volume by. So let's take a look at this one here. Going back to the prism, but this time I'm going to triple the width, and I'm going to half the length. Okay, so I'm tripling the width, halving that length. What does that do? So I've got this already there for us. So if I'm going to triple the length, so the length goes to 12 and the width goes to, no, I'm tripling the width. So the width goes to 9 and the length goes to 2. Right. Height is staying the same. Height stays at 6. All right, there we go. So let's plug stuff in. Same formula. So now I have 2 times 2 plus 9 for perimeter, times my height is still 6, and then 2 times my base, which is 2 times 9. All right. Notice both of those change. Lateral changes and also the bases change. So I have 168 square feet. So let's work out our ratio there. Remember, it's new over old. So that is approximately a factor of 1.556. All right. Volume, I don't actually even need to care about this. I don't care about that at all. I'm just going to take what I'm multiplying by. Right? That's what we saw back there. However many times you multiply, I multiplied by 3, and I multiplied by 3, so 3 times 3 is 9. Right? Over here, I'm tripling the width, halving the height. So what I can do, volume, I can just take triple for the width, half for the height. 3 times 1/2 is 3/2. And so this is what's going to happen with my volume. All right, just so you can see it, I did work it out. All right, plug in my numbers, and I end up with 108 cubic feet, and 108 over 72, new over old, is 3/2. So I can do this for volume, but it's not necessary. All I have to do is say, hey, that's times 3, that's times 1/2. 3 times 1/2 is 3/2. Volume, we got shortcuts. Surface area, no shortcuts, unfortunately. We have to work that out. And so surface area increases by a factor of about 1.556. Volume increases by a factor of 3/2. All right. So when you are doing these, if you are multiplying all of the dimensions by the same scale factor, all you got to do is take that scale factor. For surface area, you square it. For volume, you cube it. If you are not doing them all by the same thing, for surface area, you're going to have to work it out. Sorry, that's just the way it is. But for volume, all you got to do is take whatever you're multiplying it by, and that's what your volume is going to do. So as you saw on this one, I didn't even care. I didn't work any of this stuff out to get my answer. I just did it to check my answer and show that it works. But I can get my answer just by doing this right here. Times 3 times 1/2. If you double it and then, multiply the other side by 4 and another side by 3, then it's 2 times 4 times 3. Volume. Done. Surface area, no shortcuts. Sorry. Anyways, hope you found that useful. Now we'll see you in the next video.